Today we are going to discuss about the topic of data reduction techniques in data mining. Data reduction, complex data analysis and mining on huge amounts of data can take a long time, making such analysis impractical or infeasible. Data reduction techniques can be applied to obtain a reduced representation of the data set that is much smaller in volume yet closely maintains the integrity of the original data. That is, mining on the reduced data set should be more efficient yet produce the same or almost the same analytical results. Attribute subset selection. It is one of the data reduction technique. Data sets for analysis may contain hundreds of attributes, many of which it may be irrelevant to the mining task or redundant. For example, if the task is to classify customers based on whether or not they are likely to purchase a popular new CD when notified of a sale, attributes such as customer's telephone number are likely to be relevant, unlike attributes such as age or music taste. It may be possible for a domain expert to pick out some of the useful attributes. This can be a difficult and time-consuming task, especially when the data's behavior is not well known. Leaving out relevant attributes or keeping irrelevant attributes may be detrimental, causing confusion for the mining algorithm employed. This can result in discovered patterns of poor quality. In addition, the added volume of irrelevant or redundant attributes can slow down the mining process. Attribute subset selection reduces the data set size by removing irrelevant or redundant attributes, or it is called as dimensions also. The goal of attribute subset selection is to find a minimum set of attributes such that the resulting probability distribution of the data classes is as close as possible to the original distribution obtained using all attributes. Mining on a reduced set of attributes has an additional benefit. It reduces the number of attributes appearing in the discovered patterns, helping to make the patterns easier to understand. How can we find a good subset of the original attributes? For n attributes, there are 2 power n possible subsets. An exhaustive search for the optimal subset of attributes can be prohibitively expensive, especially as n and the number of data classes may be increased. The heuristic methods that explore a reduced search space are commonly used for attribute subset selection. These methods are greedy in that while searching through attribute space, they always make what looks to be the best choice at the time. Their strategy is to make a locally optimal choice in the hope that this will lead to a globally optimal solution. Such greedy methods are effective in practice and may come close to estimating an optimal solution. The best and worst attributes are determined using tests of statistical significance, which assume that the attributes are independent of one another. Many other attributes evaluation measures can be used, such as the information gain measure used in building decision trees for classification. Basic heuristic methods of attribute subset selection include the techniques that follow, some of which are illustrated in the following figure. One is forward selection, second one is backward elimination, and third one is decision tree induction. These are all the greedy methods for attribute subset selection. First one is stepwise forward selection. The procedure starts with an empty set of attributes as the reduced set. The best of the original attributes is determined and added to the reduced set. At each subsequent iteration or step, the best of the remaining original attributes is added to the set. Next one is stepwise backward elimination. The procedure starts with the full set of attributes. At each step, it removes the worst attribute remaining in the set. Third one is combination of forward selection and backward elimination. The stepwise forward selection and backward elimination methods can be combined so that at each step the procedure selects the best attribute and removes the worst from among the remaining attributes. Decision tree induction. Decision tree algorithms, for example ID3, C4.5 and CORT, were originally intended for classification. Decision tree induction constructs a flowchart-like structure where each internal node, that is non-leaf node, denotes a test on an attribute. Each branch corresponds to an outcome of the test, and each external node, that is leaf node, denotes a class prediction. At each node, the algorithm chooses the best attribute to partition the data into individual classes. When decision tree induction is used for attribute subset selection, a tree is constructed from the given data. All attributes that do not appear in the tree are assumed to be irrelevant. The set of attributes appearing in the tree form the reduced subset of attributes. The stopping criteria for the methods may vary. The procedure may employ a threshold on the measure used to determine when to stop the attribute selection process. In some cases, we may want to create new attributes based on others. Such attribute construction can help improve accuracy and understanding of structure in high dimensional data. For example, we may wish to add the attribute area based on the attributes height and width. By combining attributes, attribute construction can discover missing information about the relationships between data attributes that can be useful for knowledge discovery. Thank you.